Hello everyone and welcome. In this video, we'll be talking about Git and GitHub and why they are important. We'll be starting off with discussing some terms and concepts that are most commonly used when we use version control systems like Git. And then we'll be diving into practical applications. So this video covers a lot of details starting from Git repositories, what is GitHub, to even more advanced concepts like branching, merging, forking, and all of those other stuff as well. So let's get started with first understanding the basics of version control systems. So what exactly is Git? Git is nothing but a free and open source version control system. But you would be thinking that what exactly is a version control system? So most of us are used to working on projects within our system where we have folders specifically for each of the projects, but we generally do not maintain versions of our project. So let's say if you made a change to your project and you want to go back to it, it is sometimes very difficult to go back to the stable version of it. And that's why we have a system in place, which is called version control system, that helps you keep track of your files as well as your projects. Now, the best thing about a version control system is that it helps you keep track of whatever changes that you've made in your projects so that you can revert a set of your files, or you can go back to a previous stable state of your project, or if you want to revert the whole project to a previous version. It also enables you to compare changes across your projects very easily. And let's say if 2 or 3 of your friends are working on one single project, say for a group project, you can actually check who was the last one who made some changes to your project. And let's say if there's any issue or something breaks or something's not rendering correctly on the UI, and if there's a problem that you run into, it's very easy to answer what the issue is, who made it, and when was the change made, with all of these details right available to you right in one place. Now, think of it. Without version control system, we would have maintained something like version 1.0, 1.0.1, 1.0.2, right? So this is nothing but a duplication of a lot of code with maybe minor or major changes. And when we do or think about this process, it's firstly not scalable, plus it involves a lot of duplication of code. And if multiple people are working on the same set of code, it also means that you have to make sure that your version of the code is able to reach the other person either through email, or you use some data sharing, or you use a drive link. And you have to make sure that the latest version is being distributed across in the group. And then using the latest version, you come to one single version. And if you think of it, the process is really cumbersome, and there are multiple places where you might overwrite the code which was actually needed, and fusing all of the versions together can be a really long process. And that's the reason why version control systems are really important when you're working on bigger projects, and also when you're working on group projects, it's rather a necessity. Now, version control systems are of two kinds. They are centralized and they are distributed. Now, centralized, as the name suggests, means that there's a centralized server where which is actually being used to access the code, and as well as at the same time make any changes to the code. So if you look at this image, this main trunk represents your central server. So all the people that are working on a given project can actually access the project from this main trunk or the centralized server, and they will also push back their changes, whatever they've made to the project, to the centralized server. That means that the central server has to be always available for the people to be able to access the project and at the same time make any changes to the project. And that also highlights one major problem with centralized version control systems is the common point of failure problem. If the centralized server is not available, everything's going to go down and nobody will be able to collaborate on the project. If we look at this example, right? So changes that have to be made by Sue has to be available on the main branch before anybody else starts making their changes if you are working on a collaborative project. So essentially, centralized version control systems are really good for backup, if you want to track basic changes, synchronize files. They're also really good if you're talking about smaller teams, lean teams working on smaller projects. But when it comes to bigger projects, a lot of people, a lot of scale, and speed at which people operate, centralized version control systems are not a good option. Subversion and Team Foundation Server are two very popular centralized version control systems that you would have heard about. Another thing I would like to point out here is that a lot of you would be thinking that, Sue doesn't need to make and push all of her changes. She could just maintain a separate folder with all of her changes, or, find some way in which she can keep her stash of changes separately while others can do it. And that's exactly what we are trying to do. We are trying to remove this centralized access, but give control to people who are collaborating on a project through another type of version control system, which is the distributed version control system. So in a distributed VCS, we have whoever's working on the project, the group of people have the complete project along with its history available within their machine. In a distributed version control system, whenever you are doing a checkout from the main, which is nothing but where all of the changes are present, you're not just checking out the code, but you're also mirroring the full repository, which means you have all the history, you have all the change logs and everything present. So even if the server goes down, you can use any of these clients or the people participating in the collaboration group to restore the main repository from one of the copies available. And another important advantage of distributed VCS is that you do not have to be online, or the server doesn't have to be available all the time for you to make changes. You can keep pushing to your local repo, which is the local copy of the complete repository that you have. You only require network connection when you want to publish these changes or pull the latest changes that are available from all the other collaborators. So if you look at this example, let's say you are Sue and you made some changes, you added something called as soup, and you made these changes to the main. So once you make these changes can be pulled in by Joe. Changes made by Joe then can be pulled by Eve. Even if Eve doesn't make these changes now and makes it at a later point, Sue and Joe both will be able to pull in whenever Eve pulls in the changes. So here, people are not dependent on each other for making the changes. They can independently work together on their individual choice of changes and still be able to work together. Now, a lot of you would be thinking, what are the distributed version control systems that are more popular? So Git and Mercurial are the two popular ones. Now, why Git, right, of all the other ones? The reason for that is Git is free, it's open source, it's scalable because you do not need an active server to be available to serve these requests, make sure that the server is always available so you can keep working locally with your remote repo. It's actually super fast, and branching and merging is really, really cheap as well as fast when it comes to Git. We'll be talking about these in greater detail as we go ahead. All right, now let's come to the real question. What exactly is GitHub? Now, whenever you've worked on any project or you have submitted your resumes for internships, the first thing that is asked from you is your GitHub link, where people can see what you worked on, your projects, and other things. So GitHub is nothing but a web-based hosting service for all your Git repositories, right? A very important thing to understand here is that you can use Git without GitHub, but you cannot use GitHub without Git. Git is nothing but a local repository where it is for you to maintain your versions for your different projects. GitHub is a public-facing web hosting service. So to instantiate the differences between Git and GitHub for you, Git is used for version control, whereas GitHub is basically used for hosting all of those Git repositories. Git is locally installed on a computer. GitHub is cloud-based. Git tracks changes that are made to the files, whereas GitHub provides you a web interface where you can view all those. Now that we've understood the differences between Git and GitHub and where exactly to use what, let's first understand some terms and terminologies that are associated for us to use Git properly. The first and the foremost is the most basic one is a local repository. So irrespective of whether you're using a centralized or a decentralized tool, It provides you with a private workplace, which is your working copy, which is the current version of the project that you are going to make your changes on top of. That is what is referred to as your local repository. So you as developers are going to make changes in your private workplace. And after the commit, that means after you're sure that these changes are good to go, these changes then become part of the repository. So essentially, when you're working on the local copy of your code, let's take an example of Git. That is referred to as the local repository, where you are maintaining the version history, you are making changes, you are adding commits. So that is your local repository. When you make changes and push these changes to, say, your GitHub repository, then they become part of a repository. So Git takes it one step further by providing you the private copy of the whole repository. That's the difference between a centralized and a decentralized version. You don't just get the project, but you also get the history of all the changes that were made to it. You can perform any number of operations in this repository. You can add files, remove files, rename them, make multiple changes, and much more. Then an important concept within your Git commands, or rather I should say the whole concept of Git, is a working directory and staging area, or you could say an index. Now, this is the place where your commits can be formatted and reviewed before you actually complete the commit, right? So let me walk you through the process of what it looks like. What are the different steps that happen in a basic workflow? But before we go there are two important things that you should know. One is a push and one is a pull. Now, as the word suggests, push means that you want to send change to a repository. Could be your repository, could be any other repository. Pull is you want to grab changes from a repository. That means if this is a local repository, you want to pull some changes into your local repository. Now let's look at the very simple workflow of Git. The first thing is, let's say you've made some changes to a file from your working directory, which is your local repository. You have also added some changes. So you add these files to the staging area. So we say something called as git add. We'll talk about these commands in greater details in some time, but let's just assume that this is a command that lets you add these files to the staging area. Now, once these are present and you're sure that these changes look good, you actually perform a commit operation. What commit does is it actually moves all of these files from this staging area to the repository. And this is nothing but like, in order for you to move it to the repository, what essentially we are doing is we are picking up all your commits and pushing it together so that these changes are permanently added to your repository, so that it can also be seen by other people, can be, you can collaborate over these changes. Now, essentially, this is what you would be doing when you're working in a project. You pull changes from a repository, make some of your own changes, and push these changes back to the repository. Now, when we do all of these things, there are a lot of different intricacies of Git commands, or rather, I would say concepts. So there's something called as blob. Blob stands for binary large object. Now, whenever we talk about files, each file is coming with this version because we are making changes on top of it, and we are also maintaining a history. So each version of a file is actually represented by a blob. It holds your data, but apart from that, there's a lot of metadata that is also associated with that file. Given that it's a binary file, and in Git database, it's named as an SHA-1 hash of the file. So as a pointer, remember that in Git, files are not addressed by names internally, but it's addressed by its SHA-1 hash or unique identifier. So everything is content addressed. Not that you need to remember all of this. This is how internally all of this works. This is how it is able to make version control so seamless for you. And you would also be thinking, when we are working with so many versions of these files, and these files are also dependent on other files, how is the directory structure maintained? How are the references maintained? So we have the concept of trees. Tree is again an object which represents a directory. It holds blobs as well as other subdirectories that could be present. Again, it's a binary file that is going to store references to blobs and trees, which are again SHA-1 hashes of a tree object. So it's basically to maintain associations and relationships between directories, subdirectories, and other blobs. Now comes the important part, which is commit. Now, when you do a commit, that means what is the current status of your repository? It's again an SHA1 hash. I will show you what this SHA1 hash looks like. But for you to understand it in simple terms, a commit, again, which is an object, is nothing but think of it as a node of a linked list. Every commit that you do has a pointer to the parent commit object. And from this given commit, you can go back to multiple different commits that would have happened on that particular file or on that particular folder. And you can even go back to the parent pointer so that you can view the history of the commit. Let's say there a commit has multiple parent commits, right? Think of it as a binary tree. This is the root. There are two children to it. If that happens, that means that that particular commit has been created when a merge has happened. That means some changes came from point A, some changes came from point B, and we've merged them together to get one single output of that file. Now, merging is a concept which is a little bit more advanced for now, so we will talk about it once we are more equipped with working with these basic commands. Now, what is and how do you get started with GitHub? There are very basic commands that GitHub lets you do. One is clone. Clone means that you want to bring a repository that is hosted somewhere, let's say on GitHub, into a folder or your local machine as well. The next command is add. We just saw that when we have certain files that we want to basically commit, before we commit, we basically add them to the staging area. So git add helps us do that. This is basically for us to track our files and changes in Git. Commit is the option that lets us save our files in Git so that we can eventually push them or upload all of these commits to a Git repo like GitHub. Pull is nothing but downloading changes from a Git repository to your local repository. Now, how do you get started with version control system, or to simplify it, let's first get started with GitHub, right? I'm sure all of you have at least heard about GitHub, but what exactly it is? It's nothing but like a web hosted place where you can manage all of your Git repositories. So it's pretty easy for you to get started. You can get started with creating an account. You enter your email, create an account, you get a confirmation email in your inbox, and that's how easy it is for you to get started with creating a GitHub account. Now, once you have created your GitHub account, you can do multiple things with it. You can create new repositories, you can manage your code bases, you can add your existing projects from your local machine to GitHub. So let's look at the basics of getting started with GitHub. Now, once you have logged in and have created a GitHub account, you will be able to see two things. One is this button, which lets you create a new repository. You can also go to your profile from the top right corner. On your profile, in my case, I've added a README, which indicates what I'm doing. And I can also see a bunch of my repositories. I'll just go at one of the repositories. In your repositories, you can look at all of the files and folders. I've added a basic README that talks about what this project does, pretty straightforward. Now, let's say that I want to create a new repository, right? So let me go back to the main page. And let me say that I want to create a new repository. By default, there'll be no template that will be associated. So let me call this demo repo. By the way, repo is short for repository. And I'm going to keep it public so that it's available for everybody to see. And I'm going to keep all of the other things as default. And I'm going to go ahead and create this repository. Now, when you get started with creating a repository, you can either upload files from your existing system through Git command line or through the UI, or you can create new files directly from this UI as well. We'll get into the details of how you can use command line to create a new repo, as well as use command line to push your files, manage your versions of different code, and a bunch of other things. But for now, let's just create a new file from the UI itself. Now I'm going to create a very simple markdown file called readme. I'm going to call it demo. I'm going to say this is a readme file. And You can also preview how your markdown file looks like. Let me just give a space. And we go ahead and we basically say commit changes. Now, when you say commit, there is a default commit message that you see here. You can either change it or you can retain the default message that is there. You can also add an extended description if you're making some major changes in your repository. For now, let's just go with the default message. I commit the changes, and if you look at the project now, this is the commit that is available for my particular file, and this is the content of my file. Now let's say that I want to make some more changes to my file. So if you look here, there's an option to edit my particular file. I can say adding line number 2, adding another line to the file. And again, what we can do is we can say commit the changes. Now, if you see the default commit messages that we are updating readme.md, you can either retain the message or again add. For now, let's just ignore the concept of branches. Let's just assume that we have one version of the repo where we are pushing all of our changes. So we commit our message, and if you look at the repository, you'll be able to see that this is what our README file looks like right now. Now, if you look here, we have created a file. We have then updated our file. So we have 2 commits that we have done. So we can look at the history of the commits for that particular file. And you will see that there's a unique identifier that is associated with each of these commits. And also another thing that you can do here is you can actually go to the README file and look at how the changes have been done. So let's go to history, look at these commits. Let me see the update commit. If you look here, there is changes in green, then there is changes in white. Now, whatever is in green means changes that have been added. White represents the part of the file that is untouched or wherever there have been no changes. Another thing for you to understand, how do you look at commits or how do you understand the different changes that have been done in the file? Let me quickly make another commit to this particular file. So all I'm going to do is I'm going to remove the last part of this line, add a full stop, and all I'm going to say is commit the changes. I'm going to update the message, say commit changes. Now, when I go to the history of this file and look at this last commit message again, you'll see that there's a line highlighted in red. Red represents the part of the file that was actually removed. So these are the basic ways in which you can understand from the GitHub UI how you can create files, how you can do updations in your file, and how you can understand different commit from the UI itself. Another option for you, if you want to add files to your repository from, let's say, your local machine via UI, could be you can use this plus, you can say upload files, and you can choose the choice of your files or drag and drop your files here, add the relevant upload or a commit message, and then commit your changes. Although I would never advise you to do that when you're working on projects. It's much more easier if you are doing it through Git. We'll be now going to understand how you can do all of the things that we just did now through the Git command line.
Let's also try to understand how we can do all of these things through the GitHub, through Git client as well. That is working on our repositories locally and then pushing it to a remote repository. So let's get started with the installation first. If you're using Git on macOS or Linux, the first thing that you can check is that if it's by default available. So you can just enter git minus version, and you should be able to, if you're able to get a version, that means it's installed. Otherwise, I'll be giving you this link for the Atlassian guide that you can follow if you do not have the version available. For all of the people who are using a Windows system to do this tutorial and following along, you can use a Git installer to basically have Git available in the Windows machine. Let me navigate to that part. So I would suggest that when you are doing the setup for the installer, go ahead and use a Git bash instead of using it to be installed within your command prompt. I have personally ran into some issues when using command prompt at times. So I would highly suggest that you use a Git bash, and your Git bash is ideally going to look something like this. We'll come to details of all the things that we're going to do here. And once you have installed your Git and if everything has completed, there are two things that you would have to do. Now, when you're working with Git, you need to configure your username and email. So what we are saying is that in our Git config, configure these two variables globally. Your username is your GitHub username, and your email is the email that is associated with your GitHub account. We will be talking about how does this local repository know what is the account that is linked to our GitHub. So we will build that connection. But for now, these credentials are more than enough for us to get started with building a version control system. So I'm hoping by now all of you have already installed GitHub. So let's get started with creating our first repository. So let me navigate to shell. So for now, what we are trying to do here is that we have some existing code that I've been working on. And now I want to push all of that code to GitHub. That's generally how most of our projects look like, right? We start working on a project and then we want it to be available on GitHub for further collaboration. So let's look at what all is available. So I am going to navigate to repository, and then I have a full stack repo where I have a bunch of different files. Pardon. So I have a basic front end sort of a project that is available with me. And now what I want to do is that I want to push all of this code to GitHub. So in order to create a new repository, what we do is we navigate to the existing code base that we are looking to push. We say git init. This creates a GitHub repository within this folder. Now, how do we know or how do we check if this has been initiated as a GitHub repository? We can quickly do an ls on this file. And if you look here, there's a folder called git. Now, this folder contains all of the configs, all of the commits, all of the history that of all the operations that we are going to do on this particular local repository. And also, if you see here, there's something called as master. And this is the branch that we are working on. For now, let's assume that this is the main central central branch that we are going to work with. Now, we will be talking about further details on the intricacies of branches further down the line. So now I have all the changes that I want to be added. So as we saw, we need to basically stage these changes before we commit these changes or save these changes in our repository. So in order for us to understand what is the current status, we can use the command called git status and look at what is the status. So right now we have not added any of the files that is available. So what I'm going to do is I want to add all of these files and commit all of these files. So I can say git add and take all of the files in my current directory. And now if I check my git status, all of these files that are present are ready to be committed. And now it says that if you want any of the files to not be committed, we can unstage these files by calling git rm minus cache and the file name. Basically, we do not want to commit some files, we can individually add these files as well. Now that all of the files we are ready to commit are staged, we now save these changes in our local repository by calling git commit. And we can and we should always have a relevant commit message whenever we are making commits, in order for anybody who's working on this project to know what are the changes we are putting. Are those changes related to a particular feature? What are we doing? So make this message really meaningful. So -m is the option for us to add a new message. We say adding project files. In case you miss something, you can also add another commit message along with README, and we can go ahead and commit it. So now we get a bunch of different messages that 15 files were changed. These many insertions were done. This is our commit message. This is the branch where it was done. And that's how simple it was for us to take an existing set of files, create a new repo, stage those files, and commit those files. Now, these files are still present in our local repository. These are not yet present in our GitHub repository. Now, there are multiple ways, right? Right now, we have created a new repository, right? So there is no remote repository that exists for this. So we actually need to tell our local Git client that we need to push to a remote repository, and we'll have to set that. So one easy way for us to do that is that we can go to GitHub. Let me navigate to that page. I want to push all of this code and maintain this repo for further collaboration as well. So what we're going to do is we're going to pick up this name, like the complete URL, and we'll basically add .git to it to instantiate that it is a GitHub repo. But first, before doing that, we should always first check, is there a remote repository that has been configured? We can do that using git remote -v. And given that it's empty, that means there is no repository that has been configured for us to push our changes from our local to a remote repo. So what we're going to do is we're going to ask it to add it. So we say git remote add origin, because that's where our repository is located. And we're going to paste the link. We're going to say .git and hit enter. Now, when I check the remote repository, it's going to say that for both fetching, that is pulling and pushing, I can use the same URL. So now if I check my Git status, it will say that I'm on branch master and I have nothing to commit because there are no further changes that need to be added. So I can simply push my changes. Now, if I do a push, it comes up saying that there is no upstream set. That means it doesn't know where exactly to push. So there are multiple ways of handling it. We can either set an upstream and say that it's the master branch that I want to push, or I can simply add this while pushing. So I say git push, origin is where my current repository is located. Master is the branch I want to push to, and we'll wait for it to push all of these changes from the commit to push it. Now, if I go back to my repository and refresh the page, I will be able to see all of the changes that I had made in my local and push it to my current repository as well, along with the commit messages as well. So now if I go ahead and look at my commits, this is the commit that I've actually made from my local itself. So adding project files was the commit message we had, and we can see all of the files we have added. And that's how easy it is to create a new repository and commit your changes and have those changes reflected in a GitHub repository as well. Now, if you remember, when we started with GitHub, we had created another repo called demo repo. Now, we had created this repository from the UI. Now, if I want to make further changes into this repository, what I'm going to do is I'm going to clone this repository. Now, there's a difference between initializing a repository and cloning a repository. The difference between initializing and cloning is that when you're cloning a repository, you're not just copying the code, but also the working history, the Git configurations of that repository that helps you manage that repository, connect with all of the working history, look at what are the commits, and all of the different things. So right now we are at 3 commits. Now, what we are going to do is we are going to copy its remote URL. We're going to go back to our git bash. We're going to come out of this repo. So we are currently in our repository. So we are going to use git clone. We're going to provide the URL and have this repository available with us. Okay, now let's go to demo repo, do an ls. So currently we only have a readme file. So let's quickly add another file called index.html in our particular repository. And let's also try to make some changes to our README file. So all I'm going to do is, let me just add another exclamation, probably add another line. I'm going to save this real quick. Let me also make some changes to my index.html. Let me add a simple paragraph that says, hello, and that should be it. Now, we already know that this is a Git repository. So let's look at Git status. So we know that there is a new file that we have added, and there is an existing file that we have modified. Now, let's say if you only want to push a few changes, you can simply say git add index.html, and your changes for only index.html will actually be staged. Another thing that is important here is that instead of doing git add, then git commit, you can also do git commit -m, a. -m is for the message, a is that you're saying that also add the changes of my file. But remember, you can only do this shorthand if your existing files are modified. If you're adding new files as well, you would have to manually add all of your changes. So for the ease of things, let's just say git add dot. Now we say git status. So we have modified the README. We have a new file called index.html. So what I'm going to do now is I'm going to say git commit -m. I have updated my README and added HTML main page. And that's perfect. Now, if I look at the git status, I will be able to see that I have one commit, which is more than there is one commit that is ahead of what exists at my origin, which is my remote repo. So I can use git push to publish my local commits to my remote repository. So here again, we can quickly check our remote. So you see here, it's demo repo.git. We do not have to manually set it because we have cloned the repo. So all of the configurations are actually pulled in from the Git configurations. So what I'm going to do now is I'm going to say git push origin master. Okay, let us figure out what the error is here. Okay, we had tried to do git push origin master, but since we had already set the upstream, we didn't have to specify this. So I quickly checked my status and I did a git push and I was able to commit the changes. Now let us quickly navigate to our repository, do a quick refresh and look at the commits and if it's reflecting on our repository. So if we look here, there are 4 commits that have been done. If I go back and look at these commits, these are the 3 commits that we had made through the front end, which is the GitHub UI, but this is something that we have made through the GitHub command line. And that's how easy it is for us to connect our local repository to a remote repository and manage everything through GitHub. Now we'll quickly also look at how you can authenticate your local GitHub client or Git bash to be able to make these commits. Now, if you're using a Windows system, when you install Git bash and do your first commit, it will basically authenticate you using a GitHub ecosystem client. And with Windows, it's very easy. But if you're using Mac OS or Linux, let's look at how you can use SSH keys to authenticate and sign all of those commits that are going from your local. So throughout the video, you saw that I did not have to authenticate myself in order to prove that I am the owner of the repository that I'm pushing to because I was using a Windows system. And the Git bash basically authenticates you the first time you're utilizing the Git bash. So you can do it either through the GitHub UI or you can use a token. But if you're using Mac or you are using Linux, you need to add a new SSH key to your GitHub account to be able to make the connection between your local computer and the remote repository that you're pushing to. Basically, you need to prove that you are the owner of that particular repository that you have created. And in order to do that, what we are simply going to do is use the concept of SSH keys, where we are going to generate a public-private key pair. The public key is going to reside on your GitHub under your keys. So every time you are trying to push a commit, it's going to verify that only this private key is able to generate the public key that is existing in your remote GitHub account. So in order for us to create an SSH key, there's a very simple command that we can use. Let me go to that command. So what we need to basically do is we say SSH keygen. We need to generate an RSA DSA key pair. This is the length. And here you need to specify the email account that is associated with your GitHub account. Once you hit enter, it's going to ask you to enter the name. Since it's a test auth key, I'm just going to call it auth. There's no passphrase that I'm associating. And if you look in your current directory, there'll be a test auth key and test auth key.pub that's created. So this is the public key that we ideally want to be put up in our GitHub account. So you can just copy it to the clipboard. And then what we need to do is we basically need to go to our GitHub account. Let me open my GitHub account. And we basically need to add this to our set of SSH keys so that this is available for verification every time we are trying to make a commit. Before doing that, just do a quick check if there's any SSH key that already exists. So in my case, it doesn't exist. So I go ahead and say new SSH key. I say test auth key. I can just put this key and I can just remove this extra space here and I can just add this SSH key. And this is how you specify the SSH key to be added. The private key already exists, but you also need to make sure that that private key is available on your local machine so that that authentication can be enabled. Now, when you are adding an SSH key to your GitHub account, there are multiple ways of doing that. I'll add this link along with the video so that you can go through it if you are stuck at any of the steps. But in a nutshell, we are just using an RSA DSA key pair so that we can verify the authentication and make sure that that public-private key pair are unique for each other. And that's how simple it is for you. So far, what we've looked at is the GitHub workflow and how we do the same things in our Git. So for a quick recap, let's do a comparison between what we have done at GitHub and what we do when we are using our local Git and when we push it to GitHub. So if you remember, when we first saw how to create a repository, how do we commit code, and how do we push our changes, the first thing we did is we had created a file on our GitHub. We had written a README file. So we wrote a bunch of code, or you could say we'd written some text. The next thing that we did was actually just commit our changes. If you remember, we did not add any changes per se. Like we did not use any git add command, or we did not had to specifically ask to add its changes because GitHub already handles it for us. And we didn't even had to do any git push command to be able to push our changes because we are already live on GitHub and we are already in the repository. So there is no remote repository other than what we are working on. And that's about it. And since we're also the owners of the repository, we do not have to specifically ask to push these changes. Let's say if you were not the owner of the repository and someone else has to review your code and then that code can be added into the repository, then you can create a pull request and anybody who reviews the pull request can then further merge your changes into the desired branch. Now we will be talking about the concepts of branches, we'll be talking about the concepts of merging further on. Now let's also look at the Git workflow, which we just saw of how we can interact with our code and use version control from our command line itself. So the first thing we did here was also created a README file, made some changes to that. But here, instead of committing the changes or saving these changes to our local repo, we first had to stage these changes. And we did that by using the git add command. Now, once these changes were staged, we had to actually save these changes by doing a git commit. And once these changes were ready to go, we had to push these changes to the remote repository and we used a git push. Now, here again, if you were someone who did not have the access to basically push these changes directly into the main branch, you would have raised a pull request. We will be talking about this later. Now, that was a little bit about all of the basics of things that we have seen so far. We interacted with Git using command line, using GitHub UI as well. We started with creating a basic repository. We made some code changes. We tried to add those changes. Then we push those changes to the remote repo and then finally to GitHub. Now, in practical applications, uh, if you look at it, so far we have worked on something called as the master, right? Master is nothing but a branch. Now, so far we've only looked at one thing, which was the master branch. Now, in GitHub, or rather, I would say in version control systems, there can be cases where there are multiple people working on the same project, and multiple people could be working on multiple different features in a given project. So, in that case, you need a way in which you can still keep the main code, which is stable, running, while you can work on a copy of that code and make your changes and keep testing that. That is exactly what branching enables us to do. So let's take a very quick example. So we'll start with nothing but a master branch. Let's say we had a few commits. We did one commit, we did further 2 or 3 commits. That's what we've seen so far, right? We've all been pushing everything into one single branch, and master is the default branch that we have. But let's say that there is a new feature that you're working on, or it could be your friends or your other developers who are working on adding another feature. And they need to first test the feature before they can actually push that changes into the actual code which is running in a production system. So essentially, what you would have to do is you'll have to create a feature branch. In that branch, you can work on your set of changes, more like a sandbox environment. And only when your changes are ready, you would actually want to push those changes to production. So let's look at a few concepts to understand what branching is, why is it even helpful, and how do we manage all of this. So let's again start with the same concept. You had a few commits that you were trying to do. Now, this is what your working structure is looking like. Now, you see that there is one more feature that you need to work on. So what you do is you basically use this master branch to create new branch called feature branch. Now, when you create this feature branch, at this particular point, your feature branch is going to contain all the commits that are there in the master branch. Let's say you have made commit 1 in your feature branch and commit 2. Now, at this point, your master branch is not aware of the changes that you have made in your feature branch because these are exclusively part of your feature branch. As I said, think of it as a sandbox environment where you have made a few changes and you're testing your feature. Unless it's stable and you have ensured that it's tested, you wouldn't want to disturb the actual running code in production. And once you have made sure that your changes are good, you can actually take all of these changes and put it back to master. So that process of making changes from one branch to the other in a sync is the process of merging. Now, while this looks pretty straightforward, merging can be a tricky process. Let's look at a few scenarios which are more practical. And another question that I'd like to answer at this point is that you would be thinking, why do I need branches? Why do I need to merge? Now, think of this scenario where, let's say, there are 4 developers who are working on a single project, and each of you are working on a different feature. Now, while all of the 4 features that you work on can be independent of each other, there are times when you would be working on common components of the code. Let's say if you're working on the front end aspects of your code, you would be changing similar set of files. So in those cases, you have to make sure that every time you are making an important change, you should always be in sync with your master. So let's take another example. Now, let's say that you've been working on this feature branch for a week and it's a major feature update that you're adding. But suddenly, in the middle of the week, you get a call that there is a bug fix that you need to do. And you definitely cannot use this feature branch to, fix that bug because this is not a stable version. So, what you're going to do is you're going to create another branch. Let's call that branch a hotfix branch. And you make your changes and put it back to master. And this is what it will essentially look like. So we took another branch called hotfix from here, merged those changes back in. And after this, we merged back the changes from our feature branch to the master. Now, at this point, there are multiple places where you would see that branches would have to be in sync with each other. Now, let's look at this point called the commit 4. Now, commit 4 was the place where your master branch was used to create another hotfix branch, after which it was updated. And after this update was done, we finally merged our feature branch into the master branch. Now, there are multiple scenarios where we could have conflicting changes coming from this merge, or when we are doing this merge, we could have conflicting changes coming from previous commits in case our branch is not in sync with master. So let's talk about few common things before we go into deeper concepts like merge conflicts. So in a nutshell, what we have seen here is that branching is a very common thing that is used in version control systems. We start with a regular branch, which is our master branch. At any point, you can create a main branch, which is created out of your regular branch. And as you can see, if we create a new branch at this point, the new branch will be an exact similar working copy of what the main branch looked at that point. And we can choose to keep the new branch as is, as an independent copy, or once we know that the features of the branch that we were working on are stable, we can merge this back into the main branch. Now let's look at how we can merge branches together and what are the different kinds of issues that can arise. Now that we understand the concepts of branches and merging, let's try to do this with our own repo that we have created in GitHub. Then we have also cloned that repo locally, and we have the Git repo available with us. So what we are going to do now is we're going to create a new branch, try to make some changes, and try to merge branches as well. So if you look here, what you see here is the main or master. They are both very interchangeable. So let's first try to understand what branch are we at. So we are currently at the main branch. The star indicates what branch we are at. So in order for us to move across branches, we use the command called git checkout. And since we do not have any other branch and we want to create a new branch, we use -p option. And ideally for creating branch names, since here we are creating a feature branch, you would ideally want to name your branch something meaningful. Let's say if you're working on a bug or if you're working on a feature or a new issue, your branch name should be representative of that and it should be reflecting what you've been working on. So in this case, I'm just using it to update files. So I'm going to call it feature update files. And what this is going to do is that it is going to switch to a new branch. And if you look here, this is the branch I'm at. So now if I again check my Git branch, I am sorry for the typo. You'll see that now I am now at my feature branch. The asterisk indicates what is my current branch. Now what I want to do is, let's say I want to go back to master, so I can just very quickly check out my master. Or since in this case it's main, I can just go back to main. And now if I do git branch, I can see that I'm now navigating back to the main branch. All right. let's quickly check out our feature branch, and let's make a few changes to our README file. What we have two files, a README and an index. So you can also use a code editor like a VS Code or any code editor of your choice, and you can make your edits within that editor as well. I'm just using all right. So what I'm going to ask it to do is, let's say, development environment, make sure you have JavaScript available, run index.html in browser, and that is all that I wanted to make a change for. Now let's quickly look at the files which have been changed. So I have only modified my README file. So what I'm going to do is I'm quickly going to add my README file to the staging. Once this file is added, it's always good to look at the status before you are committing anything. Let's just go ahead and commit these changes. Let's say we have updated README file, and these changes are now committed. That means that these changes are now available in your local repository within your feature branch only. If I now go back and navigate to my main branch, you will be able to see that the README file here remains unchanged. There is no change available to this particular branch because the changes are only exclusive to that branch. Now, if we want the changes to be available in the main branch as well, we would have to merge the feature branch with the master branch. Now, in order for us to first understand what is the difference across the two, we can use the diff command. So diff command is generally used to compare what are the changes that have happened across files. And here, since we are looking at doing it across branches, we can specify the name of the branch that we want. So the text that you see here in white is what remains unchanged. And the text here in red indicates what is the text that is not present in the main branch but is present in the feature branch that we are comparing it to. So a simple way for us would be to do a git merge. We can just specify the branch that we want to merge into master. But in almost all of the practical use cases, this is not how you would push the change, you would actually go about it. So in general, let's say you are someone who is working on your set of changes, you would push your changes to your branch and then have someone review it and make sure everything looks good. And then you would want to merge those changes. So let's quickly go ahead and push our changes from the feature branch. And then let's see what do we want to do after that. All right, so we are in our feature branch. Just to give you a quick recap, we have already committed the changes, so we are just going to do a git. Okay, we haven't set the upstream, so we are going to just say -u so that it sets the upstream for us. And we want to push to the feature branch, so we'll just say push it to the feature branch. We'll wait for it to do the push. Now, if you look at the message that we have got, it is suggesting us to create a pull request for feature update files, which is the name of our branch, onto some other branch of our choice. Now, what exactly is pull request or a PR, as we have most commonly heard in the world of open source? Now, pull request is a way for us to merge our changes from one branch to another. And it also gives us instructions on how we can do that. So let's go to our repo and look at the changes that we have made. Okay, let's quickly refresh this page and look at what are the different commits that have happened. Let's go back to our main repository. So if you look here, GitHub has already identified that we have created a new branch. You can actually look at all of the branches from here. This is our feature branch, this is our main branch. So we can create a pull request from the GitHub UI. And whenever we create a pull request, we would want to take a diff, which we also did from our GitHub client. So the UI makes it very easy for us to understand that this is the branch that we are merging into the main branch. Look at the direction of the arrow. And it also says here that it's able to merge. These branches can be automatically merged. Now, because this is the happy path, right? We will be talking about merge conflicts and things where it's not so simple, because when multiple people are working on a project, there are chances that the same file might be changed by multiple people. And in those cases, it's not pretty straightforward for us to merge. Now, if you see here, the message that we have here for our pull request is our commit message that we had added. So we can either retain the same message or make it more meaningful. Ideally, whenever you are raising a PR, you should add details of what this PR stands for. So you should basically mention what are the things that you added or what are the things that you have subtracted and bunch of other details. So it has to be as descriptive as possible. Once you have done that, you can basically go ahead and create a pull request. Now, in this case, I am the owner of this repository, so I do have the access to merge this as well. But generally, when you create pull requests, you have multiple people collaborating on that pull request. People can come back with certain updates, or they can also ask you to basically change a few things. So if you go and look at the files changed, right, and I look at some of your changes, let's say it's a piece of code and I want you to update it. So I can add a comment to update it and make it more descriptive. And I can just add, like I can start a review on a specific line of code. So once I have started this review, this somebody who's reviewing your PR can actually help you improve it. You can collaborate it, and that's how PRs generally work. Now let's try to actually go back to our PR and try to merge it. Now, since I have the access to, I can. So what I'm going to say is that, I mean, ideally, until and unless these conversations and reviews are not closed, you cannot go ahead and merge the pull request. Since I'm the author, I can. So let me just go ahead and merge the pull request. I am okay with the changes. The commit message looks good. So I'm confirming the merge for the update README file pull request. And now if I go ahead and go back to my code and refresh and look at what the contents of my main files are, I'd be able to see that all of the changes that I made in my feature branch are also available in my main branch as well. While Git merge works perfectly well, as we just saw, in practical use cases, it's not going to be that simple. When you're working on a project, there are chances that master is constantly being updated by other people who are working on that project. And there are also chances that the same file is updated by multiple people. So Git naturally wouldn't know what are the changes that you want to keep, which changes are probably redundant, which changes you want to remove, and what changes you want to go ahead with. And you'll have to manually tell Git what you want to do. And that's exactly what merge conflicts are. So if we take the example of what we were seeing so far, we had a master branch, we had a feature branch, and we also had another hotfix branch. Now, what happens is that if at this particular point, we are trying to merge this feature branch into my master branch, what exactly is going to happen? Now, currently there is another commit that has been added into my master branch after I have created this new branch. And what exactly happens internally when we merge two branches is that it is going to look at the common ancestor, which is nothing but the common commit that happened before the current status. It's going to look at that, compare the diffs, and if there is no file which is common across both of the branches where there is a common change, it's simply going to go ahead and merge the branches together. That is, take the changes from the feature branch, add it to the master branch. Now, this is all simple unless there is a file which is common between these two branches that was changed both in master as well as in your feature branch. And that creates a conflict. Now, what exactly is merge conflicts, right? As we just saw it in detail, right? Let's say we have developer A and developer B. Now, developer A pulled the code from master. Developer B also pulled the code from master. Now, developer A and B both are working on a common file. So developer A has pushed his code, but when developer B is trying to push the code, he's going to get a message that you cannot directly push because there are some changes that are not available and they're already present there. It's because there are some changes already present in the repository and you're trying to push changes which do not have the current version. So Git naturally is confused and doesn't know what to keep, what to remove, and what to retain. So let's try to understand what are the different kinds of merge conflicts we have. So the one common one is what we just saw, right? When we are starting the merge process. Now, this generally happens when there are some changes in your working directory, staging area, where you have done a git add for the current project, so the merging won't start at all. So there are simple ways to treat that. But the other merge conflict happens during the merge process, which means that there is a conflict between what is there in your local branch versus what is there in the branch that is being merged, which is the classic case that we just saw. The master branch could be updated by a lot of different people, and the same file could have been changed by multiple people. So when you try to add your own changes, you wouldn't have those changes which were already made. And then there is a direct conflict because there are multiple different versions of that file, and you need to decide manually which is the set of changes that you want to go ahead with. Now, you can handle merge conflicts through command line, you can handle merge conflicts through GitHub UI as well. We'll look at both of the ways in which you can do that. Now, Git naturally tries to resolve as much as possible, but things have to be manually resolved if there are conflicting files. Okay, so we know that occasionally there are chances when this process wouldn't go ahead so easily. So let's say that I have a branch called ISS 53. Like, this is something which you would see in a lot of different practical use cases. Like, we create issues like a bug fix, we give it some number, and then that's what this branch looks like. So naturally, here we see that there is a merge conflict in our hotfix branch, right? What the scenario here is that Git is not able to merge the two branches correctly. So my feature branch basically modified the same part of the file as my hotfix branch, and I'm trying to merge it to master. So I get an error message that automatic merge, which Git was trying to do itself, has failed. That means I need to manually intervene and decide which lines to keep and which lines to remove. So I naturally go and check my Git status, that what are my files actually looking like, right? So it says that it has paused the process for now until I resolve the conflict and tell it which lines do I want to keep. So at this point, if you see, it says that you have unmerged paths, and it also tells us which is the file that was modified by both of the branches, right? At this point, we can also take a diff across the two branches and very easily figure out. We will be looking at a practical example for this. This is just to give you a brief walkthrough of what we are dealing with. Now, if we look at it, we need a way to figure out what exactly happened, right? We want to understand what were the two changes that happened in our file exactly. So Git adds a standard conflict resolution markers to our file. If you see this, the head, the separator, and a detail of what happened in each of the files. So head is nothing but pointing to our master branch. This is the feature branch that we are working on. So we are saying that these were the changes that we made in our master branch. These were the changes that we made in our feature branch. So I decided that what I'm going to do is I'm simply going to update my file with these changes. I'm going to just add this contact part in the next line in order to resolve the conflict. And I'm going to just replace the block. And I'm going to now update these changes and commit, like make a fresh commit to say that now the merge is ready to be done. So naturally, what I'm going to do now is that I'm going to check the status quickly. The changes are ready to be committed, and I can just simply go and commit. Now, you can just do a git commit -ma, which means that all of the changes will be added because this is only a simple modification that we are doing to our file. And that's how simple it was for us to resolve the merge conflicts. While this was a very simple example, um, there can be major merge conflicts if you have been working on a stale copy. So I'll give you a brief walkthrough of some of the commonly used commands, which will come in handy when we do a practical example of this. So git log --merge is something that gives us a list of commits that are causing the conflict. So we can look at the complete working history of what were the changes that were made on that particular file. Now, git diff is a very important command. Basically, lets us compare the differences across branches and across different states of repositories. Another important one is git checkout. Git checkout is, we obviously know, is a command that we use to basically switch to different branches. Then there is a command called git reset. Git reset is a command that is used at the time of a merge conflict if you want to reset the conflicted set of files to the original state. Let's say we want to go back to a state where the repository was in a working condition, where the different conflicts that are coming across branches were not present. This is generally done to make our working tree a little bit cleaner and easier to work with. And then we can decide how we want to merge these branches one by one so as to reduce the number of conflicts that come up. Then another option that you get with git reset command is git reset --mix. It is basically used to undo any changes to the working directory and the staging area. We do not want to do a complete reset, but only from the staging area. Then sometimes the merge conflicts can be huge in number. And in case you want to exit the merge process and return back to a state before the merging begin, you can just abort it. And these are some of the commands that we will be using. So let's get to it. But before we start looking at a practical example of that, a good practice when working with branches is to delete a branch that you no longer need. Say, for example, our feature branch is already merged into the main branch. So we can just go ahead. We say git branch, we say -d, and then we specify the name of the branch that we want to delete. And okay, we can simply check out master. Okay, we can simply check out our main branch. Okay, whenever it's okay. It's a good practice to delete branches that are no longer needed or have been merged into the main branch and its purpose is solved to prevent a lot of stale branches in your repository. So what we're going to do is we have checked out into our main branch. We're going to say git branch -d, and we're going to delete the feature branch. We are now, if we look at branch, we would no longer be able to see that branch. Now, let's look at an example where, let's say, you are working on a particular branch of your choice and there is some fixes that were done on the main branch and you're also working on a similar file. And now when you have to push your changes from your current branch, you need to make sure that your branch and the master branch are in sync. But when you try to do that, there are conflicts that come up. So let's try to create that scenario, and let's also try to understand how you can mitigate such merge conflicts. So let's create a branch called hotfix, because let's take an example that you were working on a quick fix or a bug fix, which took you a little longer. So now we are in this branch. What we're going to do is we have two files. Let's try to change the index.html now since we changed the readme earlier. So let's add, my bad. Let's add another classic greeting that we use in all programming languages called hello world. Let's quickly look at the diff for a moment. clearly know we have just added one line. We look at status, we have modified our index.html, so we can just use the shorthand. We say git commit -am, and then we say that we have added new line in index.html, and our commit's good to go. Now, let's assume that we have made these commits and we go ahead, and let's say somebody else has made some changes to our master branch. So let's go to the master branch. Sorry, it's called main, perhaps in hindsight. Let's say that somebody else was also working on that file from some other branch, and there were some changes that came into the main branch. So let's try to stage that. Let's look at our index.html file here. Obviously, it's not going to have the changes from our feature branch. Let's add another text here. Let's say universe here instead of the world. And let's save this. And now we can go back to our other branch, and then we can try to merge it and see if we are able to do that. So this was our hotfix branch. Let's go ahead and give it a try. Okay, now we see an error message that says your local changes to the following file would be overwritten by checkout. The reason being because our index.html changes are not available in the staging, they are local and they're not even committed. It says please commit your changes or stash them. Now, stashing is something which is a little outside the scope of this particular video, but stashing, as the word suggests, means that you can stash your changes or keep them aside somewhere and then later pick them up and then get back your changes and decide what you want to do with it. And when you stash your changes, you're actually not doing any commit, but you're trying to like pick those changes and keep it somewhere. The technical details of how we do that is beyond the scope for now. But this is another way in which you can work with multiple commits across different sort of branches. So let's do a very simple thing. Let's quickly check the status. So we have modified. Let's commit this and say updated index.html with a new line code universe, just to keep the messages different. Oh, okay. I think we should add first and then give the message. Okay, perfect. Now that we have added, let's go back to our hotfix branch. And now what we're trying to do is git merge main. Now, while I know I said in the beginning that this is not a very common pattern where we would be merging locally, but think of this scenario when you are working with different branches and you're merging those branches into main, you would want to use pull request because main branch is the one which is generally running code in production or could be the main stable copy of your working code. Here, what we're trying to do is we're trying to keep our copy of the branch in sync with our master. Now, master can change over time because multiple people are working on it and multiple people are pushing their production changes into master. So you need to always have the latest copy of master available, or in this case, we call it main. So we're trying to get all of the changes of main from into our feature branch as well. So we're going to say git merge main, and we should, okay, here's the conflict. The conflict says that the auto merging has failed. Now, I said Git is able to do a lot of things, but when it comes to changes on a same file which are not handled correctly, we have to do some manual intervention. Now, you can fix these conflicts through the GitHub UI. You can fix it to the editor of your choice. And I think the best way is to just go to the file and fix it. So we know that auto merging has failed because of the index.html file. So let's go to our index.html file and look at what is the issue. So if you look here, there are two lines. there's a head, which means that this is the content which is present in head, which is our current branch. And universe is what is coming from our main branch. Now, as someone who has made the changes, sorry, I want to retain both of them. So I am going to tell Git that I want these changes as well. Basically, this is the separator between the divs. And I want to retain the second line as well. So essentially, if I look at the Git div with master, main, there essentially isn't going to be much of a change because we have retained both of the lines, right? So what we are going to do now is we are going to say git commit -am resolved merge conflict. And now we should be able to merge the master in the main. All right, so now if we try to merge the main branch into this, it says it's already up to date because the changes from that branch and this branch are all in sync. And that's how simple it is for you to resolve conflicts. Obviously, when we are talking about bigger projects and bigger repositories, the number of conflicts that you get can be huge. And in most of the cases, you can either patch it, you can stash it. Those are more advanced concepts that we will be discussing in further videos. We talked about merge conflicts, branches. We also talked about pull requests. Now let's talk about something called issues in GitHub. So issues in GitHub basically allow you to collaborate, track changes, communicate what you want to be done in the repository more effectively. It's a way in which you can share your thoughts about what do you feel might be a potential addition that can be done in a repository, or if there's something that's not working correctly in the code that you are working with. And in general, it's a good way to collaborate because issues can be cross-linked or cross-referenced in pull requests, so they can be mentioned there. And anybody who's picking up an issue can mention it in the pull request. And once the pull request is merged, they can choose the action to be taken. They can either resolve it, they can either close it, or mark it as fixed. We'll talk about the different things that we can do, but first let's look at what and how to define an issue. It's pretty straightforward to define an issue. I've already defined one. You simply go and click on new issue, you give it a name and title of your choice, and you give a description of what you feel the issue is, if you have any background on what might fix it, and any probably ways of recreating the issue that you have run into, and as much detail as possible. And once you submit an issue, let's say, let's call it demo issue, we say description, and something, much more details. Now, once you submit this new issue, you will see a number corresponding to that issue, which is number 3 here. And now let's say that I am the developer of this repository and I have picked up a particular issue that was open. Let's say I wanted to make README more descriptive, and I want to let the issue be enclosed. So what I'm going to do is I have created a pull request. In that pull request, I'm going to mention this issue and let people know that once this pull request is merged, this issue can actually be closed. So I basically, let me go back to my Git bash. I actually committed and pushed the changes of my hotfix branch. Now that those changes are available, I can actually close this tab. Just a minute. Let me go back to my main repository and try to open a pull request. I'm going to say compare and pull request. I've added some hot fixes to the README file. I say details on how I fix the issue. And you can say closes number You can choose the issue that was basically closed by this. I want to say number 2, and I can just go ahead and create this pull request. So I have now linked my issue with a particular pull request, which is significant of the fact that I have tried to solve the problem that was there in that particular issue. Now, once this pull request is merged, this issue should also be closed. And let's go ahead and merge this pull request. The hotfixes are done. I confirm the merge. Now let me do a quick refresh on my GitHub repository. Now, if I go and look at my issues, I'll only be able to see one of them, which was the demo issue, because I merged the pull request and I had said that once this pull request is merged, close it. Now, there are multiple ways in which you can link an issue. If the issue is in the same repository, you can use the keyword and the issue number. The multiple keywords that are available is these. You can choose what the action should be. If the issue is from a different repository, you also need to specify the repository that the issue is from along with the issue number. And if there are multiple issues, you can have multiple keywords which are comma separated, and then that PR will eventually end up resolving, closing, or fixing the sort of issues that have been created. So that was all in today's video on Git, GitHub, commands that we can use to manage repositories locally, all about version control systems. We explored branches, the commands that can help you manage repositories. We also looked at merging, merge conflicts. We explored pull requests. We also talked about issues and how you can use issues and pull requests together for better collaboration and managing communication when working with bigger projects. I hope you learned a lot from this video. And if there is something else that you would want us to cover in this video, do let us know. Thank you.